All right. I think we're live. Got a couple people lined up in the chat. Tech Doofus, thanks for joining. Let's see. Let's set the stage for these live streams. So I've been tinkering a lot with some open source tools in the container space. Notation, which is one for signing container images, putting digital signatures on there. Another one, copacetic, for patching them. And then yet another one called Ratify, which is kind of an admissions controller that says, hey, do you have certain types of artifacts on your container image? And if you don't, then we're not going to let you deploy to the cluster, to the Kubernetes cluster. And so with that, I kept running into kind of a knowledge barrier with containers. You know, I've used containers for many years. A couple of jobs back, and then even at Stack Overflow, I used containers even for my local development environment, not even necessarily for packaging and deploying applications. But I've never really dived beyond Docker build, Docker run. I don't know like what's happening on a Linux operating system to create a container, how it achieves its isolation. And so I don't know, 2 weeks ago or so, I started diving into answering that question. And luckily for me, many people have kind of traveled this space before, which isn't too surprising because containers have been around for a while. The number one person that I've gained a lot of insight from is Liz Rice, who wrote a book, I think it was published last year, called Container Security. So I'm going to be pulling a lot from her talks and her book in this live stream. But to set the context, what I want to kind of do in these live streams is, one, just test out this idea of code with me. I've wanted to do it for a long time and kind of just never push myself out of my comfort zone to do it. And the general idea is just like a live pair programming experience, kind of learning as I go along through things. So this particular first session, there's going to be a little bit of catch up because I've got, I don't know, about a week's worth of code and knowledge kind of accumulated that I'm just going to kind of reviews. Yeah, finally live. Thanks. Yeah. I've been talking about this for a long time and finally just, I don't know, kicked myself in the butt to get it done. But what I'll be doing in this first stream here is kind of recreating what I've got so far. And that is essentially a sudo Docker CLI that has two commands. It has a build command, it has a run command. The run command's maybe 10, 15% developed, but the run I've got working, again, largely because of Liz Rice's, I think it was a 2017 DockerCon video, which, let me pull that up and drop it in the chat so you can check it out afterwards. 1 second. Here we go. Here's the repo for her talk that has a link to her, repo to the code base that goes to the talk. So yeah, what I'll be doing is walking through building that. And eventually I'll catch up to myself though, and it'll be just be a live stream, kind of like a pair programming type thing. If I'm struggling with something, feel free to chime in. I am going to push myself even more and try to switch what Steve Morawski, my teammate, calls zero productivity. So what I'm doing is trying to learn some TMUX and trying to learn some NeoVim. So I'm going to be coding in that instead of my normal habitat, which is VS Code. So that's enough context. Let's just share the screen and work through this. Let me switch my layout. Yeah, eventually I'll embrace the Chad Stack fully, Tech Doofus. Eventually, I'll get there. I won't lie, I do miss my Copilot, but I did learn that there is a Copilot plugin for it. So here, let's just get familiar with what I've got started, and then we'll dive into, and I'll start rewriting this from scratch just to catch everybody up with the journey, and then we'll kind of just go through it. So really what now, I've got a bunch of different files. The main one that we want to look at if we do nvim is we want to look at the main. So in here, really all that's going on is I am using the flags package because I'm not creating such of a cool, I'm not using Cobra, which is a very common framework in Go to create CLIs, just because this is more of a toy project. And my end goal with all of this is to be able to run a container with this command line using Go and using system calls. But I also want to be able to generate a Docker file that's OCI compliant. And if you're not too familiar with that, the OCI is the Open Container Initiative. And so that's the standard Spacker standard way in which containers need to be built to go on a bunch of different runtimes for containers. And so my first pass isn't going to be OCI compliant. I'm just going to try to mimic what Docker's doing when it builds an image by creating different layers and then adding them together. And I'm going to do that probably just by copying, pasting stuff around and creating archives and whatnot. That's the end goal. What we see here is a run. So you can see that highlighted on here. So I'm creating, using the flags package to create a run command, and then I'm going to a case statement, which we'll kind of figure out later. And that's what's running the container and starting up the namespace and doing some C groups with control, and I'll dive into that. And then the build, and that's really kind of where I'm currently at. So what we'll do is we'll just kind of start from zero. And a really great book that I've read in the past for thinking through command line tools, I've got it right here. Let me just pull it up. Is Marion's Building Modern CLI Applications in Go. So I'm a fan of physical copies of books, but it's great on digital as well. And it's forwarded by William Kennedy or Bill Kennedy. So if you've spent any time in the Go space, you've more than likely run across his name. So just having him forward it was a good enough reason for me to pick it up and read. But it walks through kind of how to develop and build command line tools. And one of the very first things that she talks about in the book is the idea of use cases. Like before you kind of like start developing it, you don't necessarily need to write all the tests and so forth and do test-driven development, but it is good to have an idea of like, what subcommands do I want? What flags do I want? And you kind of learn the anatomy of a CLI. Like I've used a CLI for my entire career and never really understood like the difference between a parameter and a flag, and all that's really kind of, she goes in deep to that stuff. So again, that title is Building Modern CLIs in Go. So great book there. So the first thing that I want to do is kind of, I want to create the shell of the commands. And so I created a new directory in here, live stream. And I'm just going to do go mod init. And then what is the path? Like GitHub containers from scratch. So we'll just give it that name. So that way I have a mod file. And now I'm going to create the main. So all caught up. All right. Thanks for joining, Eric. And let's see, our main.go. I could have probably created that in Metfor. We're in here, and what I want to do is kind of stub out the commands. This helps me, and I've got this kind of all set up. I typically can't write like this, but let's see this. Package main, and for now I just want to import flag package, thumped, and OS. So I want to stub out the build subcommand with two arguments. I want to have a tag and I want to have a path, and that kind of mimics Docker's behavior. It's really easy if you have a model to follow. I think copywriting or copy coding is a fantastic way to learn. So if we do func main, move my windows around. That way I can see comments. There we go. All right. So in here, I essentially want to create my two commands. So let me open up the right file. The first one I want to do is the build. Make sure I'm in the right window. There we go. So build CMD. If you're not familiar with the flags package, the flags package is part of the standard library. And it flags is for, adding, building command line tools with Go. And flag is the primary thing that flags are what you pass into the command line tool. Now I want to create a new flag set because I want to have subcommands. So the new flag set is what I want to call. So flag.new flag set. And I want it to be called build. And I want it to exit on air. So flag exit on air. And then, like I said, I want to have two flags off this subcommand. So my first one is going to be tag and that'll be build cmd.string egg. I'll probably be misspeaking a little bit here. Call me out if I do. So the name of the container image is what I want the tag to be, and then I also want a path. So I'm going to create, eventually what I'll do is I'll create my own geniusly named container image, or container file is what it'll be called, and it'll mimic a Docker file, and I'm going to be pulling from that and creating layers from the different instructions that are listed in there. So build cmd string, and this is another flag passed into the subcommand of build. And so if we do path, and this middle thing here that's empty is the default value. So I could make that relative if I wanted to, or have a default name, but Docker doesn't, so I won't. And this will be the path to container file. So instead of Docker file, it is container file. Now what I want to do is parse those arguments so that this, once they're passed in, you actually in your code, you have to parse them so that way they get assigned to a variable or added to the struct, I would imagine. That would be a better way to say it. Parse, and then OS args. So this is from the OS package is going to be able to detect what arguments are being passed in at runtime, and then it's going to assign them or parse them. So let's do 2 through 2 to the end. And now what we want to do is we'll, instead of putting all the logic in main, we'll create a function called build that'll be called, and that'll actually do all the logic of this command here. So we'll say build, and we want to pass in the pointer to tag and the targ tag and path. And then we'll end the main function. And func build, and this takes tag and path, both of type string. And then we're just going to mock it out, stub it out. So it'll be, we'll just put that out with printf. So running build with tag s and path. Once I have this built, the very next thing to do will be to start the running of the container and create all the namespaces and that. That'll be more fun. Let's see here, tag path. Missing argument list. Not sure where that's missing. Oh. Oh, yes. Separate the variables being passed in. And so this needs to be build CMD. LSense is awesome. CMD parse. All right, is everybody happy? All right, next, let's over here. So I'm going to use tmux to switch between my terminals. So I'm going to leave NeoVim in here because my witchcraft, my skills with this is not super great. So I'm going to switch over into another window using tmux, and I'm just going to switch into my live stream directory, and I should be able to run main.go, pass in the build, and then my flags, which would be tag test, and then I can put in a path of just a relative path. I could actually do like container file. What container wrong? Doesn't matter. Yeah, there we go. So now we've got that mocked out. So now what I want to do, if we go back into the code, is I want to work on the run. So I want to add the run command, but I also want to start working on the code that creates the namespace and all that good stuff. Yeah, I think I just need more time. Yeah. So I'm keeping myself in here. I haven't gone back to VS Code in a couple days, so I'm feeling like, like it might actually happen this time. What was a gentleman that said, so he actually gave me some, well, let's take a step back. Like, why NeoVim and why Tmux? Well, the main motivator for me has been, I had a manager in my last, before Microsoft at Stack Overflow. His name's Tom Limoncelli. So he wrote a bunch of really awesome books in the sysadmin space. And we were on a call one day and we're working on an outage and or an issue, an incident, whatever you want to call it. And he just opened up on his Mac the like basic vanilla terminal, and he was just flying through all of these directories and files and making changes here and there and changing like 10 files at once. And I was just astounded at the speed and productivity that he had using just the vanilla shell and using Vim in that way. And I've always wanted to. And his advice was very, very good. I should have kept with it, but he said just learn one command a day. So go in to get a cheat sheet or whatever it is, or search it, and then anytime you get a friction point, like work through that friction and pain, and then eventually, he said you'll be like me. Essentially, is what he said, and his extreme productivity in that. So I've always wanted. There's also just something romantic about the terminal. I don't know if other people feel that way, but it's weird. So I've heard like a Jocko Willink. He's got a big podcast and a number of books, and he's a former Navy SEAL commander. And he said there's something romantic about like boot camp and the difficulty there. And I don't know. I feel the same way about the terminal. It's kind of romantic in my mind. But anyway, let's start working on the run command here. So add that in. So let's hear that build's being called. We can worry about the switch statement in a second. Let's just get the command knocked out. So run CMD. We want to create another flag set. New flag set. And we want it to be called run. And saying NeoVim, by the way, is pretty great too. Yeah. Rolls off the tongue better, I think. Flag. Exit on air. Yeah, it's not used because I haven't declared anything. And I don't want any flags, because what I'm going to do with the run is I'm just going to call run, and then I'm going to pass in an argument. And so what is that called? A non-set flag? I forget the proper term for that. So that's pretty much all that I want to do, but I want to parse the arguments still. So run cmd dot parse, and then we'll pass in the OS args. So we'll have to worry about that switch statement now. There we go. So now that we have more than one command, let's just go down a little bit and we'll start a switch. So switch, I'll have to move some of the code around, but that's fine. Switch off argument one. So argument one is the subcommand that's being passed in. So in this case, it would be build or run, and we want to switch off that. There's a much more elegant way to handle this in the Cobra framework, but again, I just wanted to keep it super lightweight. And it also, I really like this saying from Todd McLeod, I believe. So he's got a really popular Go course on Udemy. But one of the first things that he says about Go is Go suffers no fools. And it makes you really understand. If you use a standard library in particular, in the language itself is just crafted in a way where you kind of have to understand what you're doing. There's not a lot of helper things. Like one thing when I was grinding out some leak code was there isn't even a set. You can't just call a set. You have to create a set. Or the linked list. Like you have to create the struct for the linked list and understand the pointers and stuff like that. And so it doesn't do you a lot of favors. It doesn't abstract a lot, which is a lot different from the language that I came from, which was PowerShell. Is a big jump. Goes statically typed, types are everything. PowerShell doesn't care, and so that was a bit of a steep learning curve there. But anyway, this is going to do a switch statement on the first argument being passed in, which would be the subcommand. So let's see here, OS arg1 case run. And this is where we'll have to move some of this stuff down. So we can move the run command in here. Just I think this is, no, that's not it. Shift V. There we go. And then we'll cut this too. There we go. We'll worry about building in a second. So create another function called run. We'll need to pass in. We can't pass, we'll just cheat. We'll not pass in anything yet, and then we'll just call the OSArgs package in here. Work, maybe. Think about that. Anyway, let's create the next case statement. So case build and then default. Build, we'll have to move all this stuff into. I wish I knew the multi-line edits. That's one thing I should add to my list of things to learn. Okay, there's that. I need a semicolon here. All right, let's do a default. And this will just print out an error. So if it's not build or run, we'll just say it's an invalid command. We need our closing curly brace. All right, now back to run. Can we passing in anything? We could just do, we're expecting one argument. It could be called arg, and it could be a string. Then in here, we could print it out. Running container with arg. And then it could be arg. That should work. Should work. But we need a call. And then it should, oh, I need to assign this to something. Args. Args. That maybe a pointer to it. There we go. I wonder if that's preserved. Invalid argument. I wonder if I need to parse them because there's not any arguments parsed into it. I wonder if I just need to pass in the args itself. Args. Not use. No, I'll have to do something with that. Oh, okay. So arg would equal run cmd args. Parsing them, I can just get the arguments from that command, and then I can pass those to, okay, then I can pass those to the run command. It should just be a single one. cannot use a slice of strings as a slice. So I need to change this to a slice of strings. Because I suppose it could be more than one in the argument. That's what slice of strings is, what the go run.args is returning. So I'll need that. Okay. So let's give this a try. Change back to here. And excuse me, just make sure the build works. It does. So go run. Better. Let's check out the run command. So run should work. I just want to type in what I'll eventually want to do is type in the location of the bash binary or executable. So that way I can start a bash session inside the container. So it's not giving me the argument. So I need to change something. Oh, probably because I'm not printing it right. What am I printing? Arg. That should be doing something. Maybe it's not a string though. V. It's not a single string. Let's put a new line into both of these just to make it easier to read. Let's try that out. Nope. It's empty. Oh, I'm not parsing them. I still need to parse them. So I need to do that. Yeah, that makes total sense. I'm not adding them into the object. So run cmd dot parse. Why they're empty. And now I want to parse all the arguments to the right of subcommand, which would be 2 and onward. So if we do os args 2, there we go. I need a. Okay, now let's see what we get. Okay, there we go. Awesome. I've kind of stubbed out both the commands, and it's time to walk through, and it took a little bit longer than I expected. We'll walk through what it does. Oh, yeah, what's going on? When did you say that? That was only a minute ago. Yeah. So what I did so far is I've created 2 subcommands using the flag package with flag set. Build has flags off that subcommand called tag and path. And then run just takes whatever that argument is, and then it's going to pass it in. So that's all we've done so far. Now I'm going to work on the container stuff, and I'll pull up some of my notes and stuff like that so you can kind of get some more terminology or background into these things. So let's go and look at the first thing that we want to do. So I thought it was super useful. So in Liz Rice's book, Container Security, that's from O'Reilly, I believe, she did a really good job of walking through what each of these things are. So broadly speaking, what I've learned so far with containers is there's kind of 2 elements that make the container a container. One is the isolation. So VMs achieve isolation differently than containers. And containers achieve that through what are called namespaces, or at least on a Linux container, there are namespaces. And so what I want to first work on is how can I use Go to create a namespace? And then the namespaces have several different things. You can, what are the different names? There's, I think, 7 different namespaces, but one of them is the UTS, or the domains and the host name. So that's how you get isolation from the host the container is running on. is through the UTS. I believe it's UTS namespace. So I want to create that and I want to isolate the host name. So we're going to do that first. And then we'll move on to isolating like the processes. So inside the container, you will only see processes running in a container, and there's a little bit more to that. And then we'll also you will use croot or chroot to change the file system. So that's what we're working on next, is using the run command to kind of create some isolation. And then lastly, we'll do some C groups to limit the resources that the container has access to. We'll limit the PIDs, the processes. Yep. So the reason why I'm building this is because it's kind of cementing all the knowledge and it's connecting it all. You can kind of read it and run some bash commands. But until I go and like actually write something and apply that knowledge in some fashion, it just doesn't stick. So that's my primary motivation here. And hopefully after this is done, it won't take you nearly as long to kind of follow along and kind of learn the same lessons, but much quicker. All right, so let's start working on isolating the host name, because that was a really good example. And I need to find my PR for that. Yeah, isolate host name. So if you're curious, I've got a previous commit that I'm working off of. I'm going to throw in the chat how I send messages on the screen. That would be cool. Does that work? Oh, hey, there we go. Yeah, that's way too that's way too much to type. So I would check out the comments here. But that is a commit that I did, where essentially that's what I'm going to try to recreate, but with an additional subcommand to isolate the host name. So let's work on that. So let's see here. Going to run, let's start adding some stuff to this. And I forgot to ask, hopefully the font size is good, or like the screen size is good. Got a couple people watching. Give me a yeah or nay in the chat. Probably should have asked that sooner, but it looked good to me when I was tinkering. So let's get started here. So the first thing we want to do inside here, we've got the run subcommand, and now I want to start to do some system calls to create these things. It's new event, so it's perfect. Yeah. Let's see here. Font size is good. All right. Thanks, Eric. Appreciate it. Got someone from Brazil. Welcome. All right, here we go. CMD. Well, first, I don't know. Let's leave the print line because I like knowing how I develop. I like fun print line stuff. So let's hear CMD exec. Now this is pretty interesting. So we're going to use the exec package to run a command. So this would be like running an interactive command at the terminal. And then say here os args 2. And then we're going to pass in os args 3 and then iterate through that. So 3. Like I said, a lot of this stuff with the container isolation I did get from Liz Rice's presentation. So I won't even pretend that I understand exactly what every single thing in here is doing. But I do know that the CMD STDN, what I'm doing is mapping the OS streams to the command. So that way they get output to the terminal that you see. So if we do equals OS STDN and CMD standard out, ST standard here, we want OS standard error. And that maps it all. And now we're going to do the system call. And I don't know much beyond the system calls, but those are the set of instructions that are going to be set to the kernel and then back. And so that's how you're going to be interacting. And they use that to create the namespaces. And then the C groups are actually controlled by files, which we'll see in a second. So let's do our first system call. So this is from the sysproc attribute of the CMD. So sysproc. And I probably should import package so I can get some intelligence. This is call, and I want the OS exec as well. There we go. Preference system. This is call. Attribute. And we want to clone a couple flags. So clone flags are going to be the system syscall.clone, and I want the new UTS, new underscore UTS. And again, that is the namespace that's going to control, I believe, the domains. So on a Linux system, it's going to control the domains and then the host name. That's going to isolate that particular portion. No new, yep, we don't need that. Thanks. So now we'll call the command. So this is setting up and configuring the CMD that's going to be executed. And now we're actually going to call it. So CMD.run. So that actually execute it. And then we got to handle our error. So if error not equal nil, we're going to panic. Now, what's interesting here, see if I'm remembering this right. So with this first system call, what's going to happen is if we use that and we don't create another process inside of it, the process that initially called to create the namespace isn't going to be running inside the namespace. It's going to be the call that it's going to be the executable that called the namespace. And so what we need to do is create a child process that is spun up inside of that afterwards. So it'll be, we need to create another function called child that will be able to create a process that's inside the namespace. And then that process we can manipulate and control with the C groups and also with the namespaces. Sharing a GitHub link. Yeah, absolutely. Let's see here. So the GitHub link to what I'm hacking on right now is right here. Hopefully it makes it through. If it doesn't make it through to LinkedIn, let me know. It's like it's going to YouTube right now. And I'll throw it up on the screen. Just hope it might look better. It's a shorter URL. Actually, the easiest way would be just to go to my GitHub, which I'll put a link here. And then it's containers from scratch CLI is the repo. Where did I do that before? If we go to banners, let's create a new banner. So there's my GitHub. Let's not make it move across the screen. That's kind of annoying. There. Why is it moving? Shouldn't be moving. Save. Now show. There we go. So there's my GitHub. If you go there, containers from scratch CLI, that's the code base I'm working off of. I'm rebuilding a couple of the things that I've already done just to kind of show off the container isolation aspect. And then in future streams, I'll be diving into creating the build command and working from there. But thanks for the question. All right, now where were we here? Oh yeah, just to reiterate. So at the first call, when the run command runs, it's going to create a namespace, but that process that called it isn't in the namespace. So we need to create a new process that's inside. And so we need to do some kind of a trickery there. Luckily, Liz figured that out already. And so I can just kind of copy her code, pretty much. So if we come back here, I think that's the run command. Is this the right? Am I referencing the right? Yeah, isolate host name. So right now it's not going to work. Let's see what would happen if this. Let's just figure it. Let's run it and see what happens. Let's write that and go back to terminal 1. here. Be sudoing these, creating namespaces. Here we go. So now I'm inside of a namespace that has a unique UTS namespace, but I can't necessarily change the host name. So I think if I were to change the host name now, let's see here. Host name to match the host. Let me just pull up some of my notes quick. I can share that. Oh, let's run that again. We can say, hopefully I don't change my host name. We'll figure this out. Host name, just to make sure there's that. Let's repeat that host name. Now let's set it to container. Sorry. Host name container. If I look at the host name, it's changed, but when I exit this, it won't stick and I can't set it in the program beforehand. And now if I do host name, we're back. So that proves that here's the isolation for the host name. If we run this again, now I'm inside the namespace, the UTS namespace, and it's pulling the host name from the host. It's sharing it, but I can overwrite it, and now I've created the isolation for the host name. So if we do, like I did before, host name container. Oh, Alice isn't going to do anything. Host name. I have changed it, but I'm not changing it before it starts, and that's where that child process comes in that I was mentioning, to be able to do that. So if we close this now, I can see that I've left alone the actual host. So host meaning the container host, which is my WSL instance here, is unchanged from modifying the host name that was running in that unique namespace, also called a container. So there's that. Well, thanks for joining, Andy. Yeah. Long time in the making. I hope to make this a more regular thing. And just speaking through this is super helpful for me. It's, I'm getting the repetition in there. I'm trying to share what I've learned. It's way better than just kind of reading the book and it kind of falls out of your head. So if this adds value, it's fantastic. So we'll continue to work through this. So if we go back in here, right now what we've got is a working example that isolates just the host name, but we want to be able to do more than that. I want to change the host name when it stands up. And like you saw, what I was able to do manually was spin up the namespace, and then I'm in it. I'm in the bash. That was that second parameter that was passed in. So it's setting up a new namespace for me, and then it's creating a bash session inside that. And once I'm in the bash session, or a process that's running in the namespace, I can change the host name. But I want to be able to do that before the container starts, so I know I'm in the container. And I think Docker, well, of course, Docker creates a random host name for each container that it spins up. So let's modify this a little bit so we can rename the container at startup. So if we go up here, the first thing we'll probably have to do is we'll comment out this, and we're going to do, this is another trick that I learned from Liz, which is we're going to have the process call itself. So it's almost a little recursive inception mind bending going on. But if we do cmd exec.command and we call this particular file, which is, well, I suppose it's an executable or binary, self, we can do exec. So inside here, it's actually going to call itself, and then it'll go through the switch again, and we'll add a case for child. And that child process will do the host name stuff and the C group later on, and then it'll go back up through and run the other stuff. So append, and we want to do string child. So this is when it's calling itself again, executes, it's changing the subcommand that's being passed in to child, and that is what's going to trigger the case to pull the child function. So then we'll pass in the arguments, os args, and it's going to be the two. Again. So there's that. And again, we only need the UTS to manipulate the host. Right. Okay. So now the next thing, let's go up to the case statement and add that in there. Switch. I suppose it flips either way. It works fine. So add another one for child. What's up, Mitch? Got Mitch in the chat. Old college buddy. Played some Call of Duty. Oh, what other games were around? What was that? This is one my wife calls a fairy game. Aeon or something? Mitch, do you remember? I remember. It was like a WoW competitor. Needless to say, lots of hours spent gaming in college. Let's see here. So much for I probably old is right. Yeah. No, I did play. Well, the funny thing with Diablo 2 was so I had figured out how to install, Aeon, Diablo 2 on Ubuntu, which back then, what was this, 2008, 2009, was kind of difficult. Probably still is. But anyway, I had played that game so much previously in high school and stuff that I didn't need sound. So I got the game working on the laptop on Ubuntu, and it would play just fine, but I couldn't get the sound driver to work. But I didn't need it. I heard it all in my head. I'd go through the den of evil and I'd be able to kill stuff, and I'd hear every little action. It was super weird. But that just goes to show, what you put your mind to or what you spend your time doing, it just sticks in your brain. All right. We want the child here. So child, what do we want this to do? We want to parse it and then call another function called child. So run CMD, and we're going to have to move that initial call to create the flag set above the case statement in a second. So what's Mitch saying? Baked in sound. Yeah, pretty much. Pretty much. All right. So when this is called, let's just print out that no, we don't need a printout. Let's call the parse. That's right. os.args to, again, child is being called somewhat like it is essentially a subcommand. So again, I want everything after it, and that's what's going to grab that bash again and bring it through, or whatever I'm passing in. So I'm doing bin bash, and that's what's executing that executable on the file system. And right now it's sharing the file system, but we'll change it to use a different one. We can change it to Alpine, and then we'd have to give a different path to the shell that it's using. All right. Thanks, Adam, for the compliment. Appreciate it. And now in here, wait, where am I? Getting lost. There we go. We need to get the argument again. So cmd run cmd.args. And then we want to call child. And child doesn't exist yet, and it'll yell at me, but that's fine. But what we do need to do, since we're using a flake set for two cases, I have to move it. So let's move this just up here. So it makes it happy. And all this would be much prettier if I was using Cobra. So now we need to create the child. And in that child, we will set the system name, and that'll be done with another system call. So if you come down here, or let's create another function, child, and it's going to take just the arg the same way. I guess it could be plural, but the slice of strings. It needs to do that. So in here, I want to do another func print because I want to see that it's being called properly. That's kind of my debugging I add in here. So from process in the namespace. Because if we were to put it in the main run, it's not inside the process in the namespace, so it would change my actual host name. It wouldn't change the container host name. There we go. Running from namespace, and we want to. I'll put what the argument is. Arg. Yeah, that's a real dev. Yeah, I found out I'm not the only one. I don't know if it's people that come from a sysadmin background, but I see some, I don't know, people that have CS degrees do it too. So it's hit and miss. If I'm doing something super tricky, like the logic is pretty crazy, I'll open up the debugger, but that's pretty rare. Pretty rare. So LinkedIn's where it's at, huh, Eric? Oh, interesting. Interesting. I wonder if the Twitter X stream worked. That was a more annoying one. Is I couldn't link to the link because it doesn't let you schedule them. Anyway, it's getting better, I suppose. I don't know. Oh, Sprint, yeah, because it adds it because it doesn't add a new line at the end. I'll have to give that a try. I usually use that one, the S. This I call it the Sprint F. When I'm trying to concatenate stuff, like combine variables and whatnot. So. All right, where was I here? Oh, yes. We want to call another command. Command inside the command. So what we'll do here is command cmd is going to equal exec dot command. And we're going to pass in those arguments again. Arg2. So that would be what's being passed in after the run. os.arg args3. There are any additional. And we need to map the standard outputs, inputs. Adam say, Twitter needed premium to respond in chat. Oh, that's disappointing. Can't even respond in chat on the stream? That's annoying. Huh. Is it premium now? It's not verified? Changing the terms on us. Let's see here. CMD OS equal. I should stop. I should say the full thing instead of STD. It gets confusing. Error. So we got all that. Now I still have to create the system call to set the host name. So let's do air equal syscall dot set host name. And then I think it has to be coming in as bytes. Byte. And then we can do container. So I want to change the host name to container like I was doing at the command line. There we go. And another. What am I missing here? Oh, I'm missing a comma. So if air equal nil. And then we have to call the CMD to run. So air CMD dot run, and this is what's going to execute the setting of the host name. So that should be it for isolating the host name. Switch over. check that out. So we're running in the container with this argument, and then it hit the child process. So it called itself, went into the child process, or child function, and then said it's still being used, still passing in the bin bash, and then it changed my host name. So if I exit this and do host name, unchanged. So let's just take a quick review of all that. And it's all inside the run. So we're making a system call to create the new namespace, and then we're changing the host name of the system call. And then right there, you've got your code to isolate the host name inside of a namespace, which is pretty cool. So if we've been talking about namespaces, but like what is a namespace? So I don't know if you've been following me for a little while, but I went down like probably too deep of a rabbit hole with note taking. So I always have notes floating around. And so as I was reading the book and stuff like that, I was trying to figure it out. And so like if you were to define, this is kind of my synopsis, I guess, for a namespace. So a Linux, a namespace is a Linux concept. So it's tied to the Linux operating system. But it's a feature that it provides isolation with various resources, and that includes different file systems. So here are the different, let's make this a little bit bigger. You can hit the right keys. Here are the different namespaces that you can have. Okay, so you can have the Unix time sharing system. Again, that's where the host name and the domains were. The next on the list is going to be to isolate the process ID. So right now, if we go back in here, the problem, we're not fully isolated yet. If we start up a container, again, because if we do this, we can see all the processes that are running on the host. And so we want to confine them to only the processes that are running inside the container. That's what provides the isolation there. But if we look at the notes here, we can also do mounts. So you can mount in different things. We'll see that where we have to mount the processes. What is that called? A pseudo file system. And that way the namespace will limit the processes to only seeing what's inside the namespace. But if we don't mount it, then the processes being written to that directory won't make it into our view, so to speak. Networking, and so that's how the networking gets isolated, and then users and groups, and then the control groups also are also called C groups. We'll see that, and that's the other apparatus to limit the resource consumption of the processes running in there. So anyway, I don't know if I fully read this. Yeah, I did. For different namespaces provide different forms of isolation. If you want to view the namespaces, we can use the ls namespace. So while that's running, if we were to split this, oh, what's the tmux command for this? I think it's %. Oh, look at that. I remembered. I have to bounce over to it. ls namespace. So we can see all the namespaces. You do get one whenever you have, like your host will have one namespace for all this stuff. So there should be, I would imagine, I wonder how I could see the namespace that's being in the container. They're going to show me the host. Oh, yes, because you have to be in the root, logged into root. So a lot of this stuff that you're manipulating with all this code, it needs to be run as the root user, not even if you're one. So we should see, yeah, there we go. We can see the duplicate UTS systems that were created when I started up the container. I believe there's a mechanism that cleans them up. I couldn't find too much on it yet, so that would be another point of research to figure out like how do the namespaces get cleaned up. So anyway, back to this. We'll exit the container. Yeah. A process is always in each namespace of each type. Okay, so every process that we have, and in this case, it was the bash instance or the process, has to be attached to some kind of a namespace, which makes sense. Hopefully that brings some clarity to a namespace. It took me a little while to, I don't know, kind of piece the puzzles together. All right, now that we have host isolation, let's start hacking on. I think we want to add, what would be next? Let me look at my run command. Oh, we set the host name. We could change the root directory next. And that's all done in the child. Could do the PID. I think what I'll do is we'll mount a new file system. That's what we'll add. So if we go, let's see here, let's go back over here. Oh, wrong window. Back in here. Yeah, let's just do that. Let's work on the file system and then we can work on the process. The PIDs, I think, would be next. Yeah, let's work on PIDs. So come in, let's see here. Let's go with process. So we need probably need a new system call in here to do PIDs because right now we only got the ETS. So let's pipe that and add another one. Sys call clone new PID. All right, now let's add it in. So we've got it being created. Now we have to do something with it. Oh, okay. So here, let's see here. Let's highlight this. This is going to create the new process ID namespace. But if I recall, that's not going to limit us. Well, it'll isolate the namespaces, it'll isolate the process namespace, but it won't populate the proc directory. So all the processes I think are stored in, is it slash? I think I have a note here somewhere. That's the mount. Is it up here maybe? Isolating the process. And processing information. So if we just created a namespace, it would isolate it, but we wouldn't be able to process information. And so what we want to do here, you have to change root for that? I don't know. I know you have to mount it, but I want to know, oh, it's just slash proc. All right, let's figure that out. Okay, so here's all the processes. And we want to mount that into the namespace. All right, we can do that. It created. Now let's mount it. I don't know. I don't know if I need to isolate, if I need to change to the ch root first, or to root, however you pronounce it. Why would I need to do that first? I don't think I need to. Let me open up container security and see if that has anything in there. Isolating process IDs. Oh. Interesting. No, I don't think I need to combine them just yet. Let's find out. So if we create the namespace and we mount it, I think that's all we need to isolate the processes. And here's where we'll do the mounting. I want to mount the process. 0. Okay. So now we're mounting the process directory. I wonder if that would just call mount. Let's pull that up. It says call mount. Let's look what that's taking. Mount. Got a source. Where is it coming from? It's /proc or proc. Targets me proc. The file type. That's what I was thinking. I was confused by. The FS type is also proc. So it's a pseudo file system type proc. So I wonder what other values you could have. It takes a string. I don't know enough Linux to know what the other file types could be mounted. I'd imagine some kind of a disk volume or something like that. So there was that. So this should give us isolation of the processes, I think. And then I think we want to unmount this if it's running. So if error. This is a cool little Go trick. If you can kind of wrap your call in an if and catch errors at the same time. I know there's there's an idiomatic term for it, but it's escaping me at the moment. If I want to unmount this after it exits, after the process runs, unmount host. So panic. Oh, that's in here. Oh yeah, missing this. let's see if this isolates the processes. Yeah. Here, such file. Oh, so this is why I need the processes. Line 71. Okay. No such file or directory. What was it? 71. No such file or directory. Oh, that's why I needed. Okay, so here's the code from before. I'll just pull it over so you can see. I'm wondering, so it was changing the file system and I'm not giving it a relative path. So before I was changing the root directory to Ubuntu FS because I had that local, and then that obviously has the proc path, and then that would be, I'm changing the directory to the root, and then okay, that's probably what it is. I wonder if I just change the code to point to the host's process. But then that wouldn't separate. Okay. Now that's making sense. To have its own, it needs to have its own proc file to mount to. That's making more sense now. So I do need to root before or as part of isolating the processes. So it has its own process pseudo file system that can be populated. Hopefully I'm understanding that right. Let's give it a try. All right. Well, if we look at, yeah. Let's look at the file system. ls copy in. Let's just move or copy the Ubuntu file system. So this would be part of the build that I'd have to do. Right now, I'm relying on a previously downloaded rootfs system. And so just for simplicity, let's just copy. I don't know if it would move it all over. Ubuntu. File system here. We do want it to be recursive. So now I have a Ubuntu root file system relative to where the code's going to be running. And okay, so now I need it to root. That's why I needed to have that. Okay. All right, so let's take a step back since now that we know that, let's remove the process calls and mounts because that's not going to work until we have our own file system to mess with. And we'll add in changing the root directory with some system calls. So let's delete that and then delete the cleanup, the unmounting. I think I added it up in the system calls, yeah, for the namespace. So we'll revert this back. I will. So we're back at just isolating the namespace for the host name, brain starting to hurt, and we'll change the root directory. This is all underneath the child. If error equals syscall. And I think the file system was Ubuntu FS. Check. Ubuntu root FS. If error is not equal to nil. And once we do the process, it'll be a good place to stop, and we can work on the build command next time. Okay, so we've changed the root directory, but we also want to change the path. So it's not, so we know where it is. So I think if I remember correctly in the talk, Liz Rice said that if you don't set the path, it's kind of a random where it sets you. So she recommended that you do this, where you do syscall change directory. Just go to the root. So now if should give me my own file system. Oh, cool. All right. I wonder, let's see here. Let's exit. So this appears to be its own file system, and then it has its own proc directory, and we don't see any processes in there. That's because it's not mounted and there's no namespace for it. So if we close this, isn't a nice little file. So if we look back in the directory, what I did before is I placed this Ubuntu container root just to signal, because I'm creating a Ubuntu container, but my host is also Ubuntu. And so the file systems look very much alike. So I'm just going to copy in that Ubuntu marker, for the lack of a better word, into that. And so now if I were to run container, that should exist when it's mounted. There we go. So now we've got host name isolation and we have its own file system. And so what Dr. Bill would be doing would be creating all this file system from all the layers for the container. That makes sense now why the processes wouldn't work, because it didn't have its own process pseudo file system, which is why you need to use Turret. All right. So if we go back, wrap up by mounting and creating a namespace for the processes. And then we've pretty much, I guess we could do C groups, but we'll leave that for the next stream. And that would be how to constrain it. Because right now, if I were to start this container and I'd run some kind of a stress command in there, I could actually consume everything, all the resources of the host. And C groups are how you change that. So let's worry about the process mounting now, so we can get our own processes. It looks like I didn't have a commit for that. So if we look at, and again, if you want to get the code and follow along, we put that up in the chat again. Just on my GitHub, containers from scratch, CLI. All right. Main, probably in the run. All right, let's create a new PID namespace. There we go. That's what we need. System call to create a new PID. Now we need a mount. That'll create it, but it won't do anything. Well, actually, let's just be curious here. Let's not mount it and just see what happens when we create the namespace, if it gives us an error still. No. But if we ls proc, there's nothing in there. So we have to mount into the namespace with a mount namespace. So now inside, go down. We're in the child function. Cool. After we've changed the directory, now is when we would want to mount the process, because then it would be, you'd be able to see it. Otherwise, we have to give a different path to it. So if error syscall, proc 0. Oh, and arguments. Another proc. Target destination or source target type. There we go. Okay. Test it out. If we do PS, got the XE to get in and the bash, and then the PS process that I just executed. And then the number one tip that this is isolated from the host is if we, well, I suppose we could split the terminal and look at the host and do PS here. See how the PIDs, the process IDs are way higher. So over here, I've just started like 13 and 16. Oh, I made it weird. Reissue the commands. ls proc. Way lower. And then if I do a PS, I'm only seeing what's been run inside here. I wonder if I could do like host name. I don't know if that would spin off a process or not. And then here, they're way higher, and there's more of them, obviously. So there's how we were able to get the isolation with the processes. Again, if we switch back to here, that's all done because we needed to, one, create the namespace. So if we, that's on line, oh, this one, 48, clone new PID. So created the PID namespace. Needed to create a new root directory, so it had a new process, like a target for the processes to be installed in or put into. Cool. I need to change to the directory. All right. So I think that's it. I mean, there's other ways that there's other things that you can do to isolate like the network. I'm not going to worry about that in the CLI. Although I probably would have to if I was going to get it to run on Kubernetes, but we'll worry about that later. The next thing that I need to do to refresh this is to work on the C groups. And then we can work on the build command. And at that time, we'll probably refactor this a little bit because right now it's all just in main. So all these functions like child, run and build, I'll probably just do build and run. I'll turn into different commands. Okay. I think that's a good stopping point. Feel pretty good about it. It was super helpful to walk through all that again. Yeah, good stopping point. So yeah, if anybody's hanging around, thanks for joining the stream. We'll do this again. I'll probably do it sometime next week, early next week, where I'll dive in and maybe I'll just pick up where I left off, and we'll dive into the C groups and then also the build command. So just like a general recap here, what we did was we created a Go CLI. Has two commands, build and run. And we worked on the run command to isolate the host name of a container and the processes, and we changed the root directory. So all three of those things are happening when you create a Docker container. But now, hopefully you get a better understanding of what's going on when you run those things. I know I do. So that I won't take up any more of your time. This was super fun. I'll catch you on the next stream. Probably the best place to catch up would be, Twitter or X is the best place. That's where I'm most active, but definitely LinkedIn and then YouTube, where I'll be streaming these too. So if you connect to me on there, those are the best places to get notified. At least YouTube and LinkedIn, I can have an advanced schedule of that. But yeah, we'll pick up next time with C groups. Thanks for hanging around this whole time. Thanks, Eric, for hanging around. You've been around since the beginning. Appreciate it. And yeah, I love this. Has actually been a fantastic excuse to dabble in some more Go. So any excuse that I could do to write some more Go code, I'm on top of that. So yeah, thanks for all joining. I'm going to end the session, end the stream, and hopefully catch you on the next one. Thanks.